So in the text, question number 7. Suppose that y is 1 over x, y equals 1 over x. So this is called, of course, your inverse relationship. And the translation just shifts to the right 3 and up 4. So find the image of these, and these. That's fairly straightforward. Remember, if I were to take this right here, and pretty much you just add those right there. So plus 3 there, plus 4 there. So just to give you that, that's a 4 and that's a 5. So 1, 1 translates to 4, 5. Repeat that process for the other ones. So question is, now verify that the 3 images satisfy t under y minus 4. So remember where this came from. What we did was take the x minus 3 and replaced it right there. And we take the y minus 4 and replace it there. So that's exactly what's there. So that's what the graph translation theorem states. That either we can individually just shift parts of the graph, so shift the points, or we can substitute in to the function to make a new function. So essentially, all we're saying is, when I take this 4 and put it there, I should get out the 5. You're just verifying that it works, okay? So let's just test it real quick with this point, and you can do the rest on your own. So y, undo that. So it's this 4 minus the 4 that's in the problem, 1 over, and I'm going to go ahead and throw in the 5 right there, minus the 2, minus the 3. And let's see what we get here. 0 equals 1 over 2.
And 5 for that.
Good. So here I messed up. All right, so now let's do, I'm going to put not the 4, but the 5 there and the 4 there. Hashtag epic fail. So 5 minus 4 equals, I'm going to put a question mark because I'm not exactly sure about that. 4 minus trace. 1 equals 1 over 1, and 1 does equal 1. So now we're checking. Good. So looking at number 8 here, the graph of f of x's radical x is right here, is shown at the right, together with its image under translation, which is this red one here. The image of 0, 0 on the graph is the point, it goes up to there, it shifts to there. So find the rule for the translation. So what we have to do is figure out what's going on. Notice here that we are going up 1, 2, 3, so that the y is changing by 3 that way. And this one here is going left 1, okay? So the rule for the translation could sound something like this, t 0, 0, and we already know what happens with that. So let's try that.
Does it matter which one you do?
It doesn't matter which one you do, I just want to be consistent. So the point t 0 becomes, and all we do is just change that to be negative 1, 3. Like so. Find the image of 9, 3 under this translation. So we subtract 1, subtract, and add 3 to that. So the answer there, just mentally we can do, is 8, 6. Like so. Now find the equation for image G. So the equation requires me to actually substitute in the opposite of what I see. So in this case, since I am going left 1, I'm going to substitute in an x plus 1, and that's going to get put in for x. So all of that is going to be in the radical. Next, this is saying plus, so I have to replace this one with y minus 3. So the f of x becomes y minus 3. Remember that f of x and y are pretty much synonymous. And the x plus 1 gets shifted into there. So let me just work through that real quick and see what happens. So this is y minus 3 is equal to the square root of x plus 1. And now let's solve for y to put it in function form. And here's our result. X plus 1 outside the radical is the plus 3. And that's what we get. Now let's look at question 10. In 10 and 11, rules for two functions are given. A, state the rule for a translation that maps f to g, and graph f and g on the same set of axes. Okay, so the graphing is actually not complicated because we can essentially just do it by hand. So state the rule for the translation. In other words, what is shifting? And the only thing shifting, notice that g of x and f of x are the same. There's nothing being added outside the basic parent function here. So the only thing changing is that the x is shifting. So the description of it is that we're shifting. We shift the function just to the right 2. That's all we're doing. So how do we describe it? So I'm going to say 0, 0, and that becomes 0. Sorry, not 0, but 2, 0. Just moving everything over. Alternatively, if we wanted to focus on the other method, we just say translation of this point here is mapped to 2, 0, like so. Okay, now graphing them on the same axes is not too crazy, so I'm just going to do a quick sketch here. Remember that here's my basic function right here. Starts there, and it kind of does that. All I'm doing is shifting the whole thing over 2. So now it goes to there. And I'm going to repeat the graph just like that. So notice that here is not necessarily parallel, like it does get shrunk there. It's underneath this, looks the same as underneath that. So you should graph it a little bit better than that. This was just a quick sketch, but all we've done is shift each point over to the right 2.